Hello everyone. So today let's solve the problem similar pairs, right? So this was asked in the code forces around 644 for the division 3. It's been ages that we have solved the problem on the division 3, right? So yeah, this is one of the div 3 problems actually. Yep. So this was asked in the code forces around 644 for the division 3, right? So let's see what the question states here, man. You can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Yeah. So just give me a second here. What happened to this one? 1 second. Yeah. So here, yeah. So what the question states here, we are given an even length array of positive integers. Even length array of positive integers, right? So we have been given even length array of positive integers, right? We have to pair all the elements so every element appears in exactly one pair. We have to pair all elements. So we have to pair all the elements so that every element appears exactly in one pair. Every element appear exactly in one pair. A pair is valid if both numbers have the same parity. Just remember this one. A pair is valid when or if both numbers have the same parity, right? If both numbers have the same parity. Yeah, this is fine, I believe. A pair is valid if both numbers have the same parity, both even or both odd, yeah, or they differ by 1, right? So a pair is valid if both numbers have the same parity, both even or both odd, both even or both odd actually, yeah, or they differ by 1, or they differ by 1 actually, yep, or they differ by 1, yep. So we have to print yes if such perfect pairing exists. If we have to print yes if the perfect pairing exists, right? So I'll just write here perfect pairing. Yeah, I'll just write here perfect pairing P. Else we have to print no. Else we have to print no. Yeah, this is the question actually. Let me read the question loudly. Just listen to this carefully. So we have been given an even length of positive integers. Yeah, we have been given an even length array. This one even length array of the positive integers. We have to pair all the elements. So every element appears in exactly one pair. Exactly one pair. Yeah, this is fine, I believe. A pair is valid if both numbers have the same parity. A pair is valid if both the numbers have the same parity, both even or both odd. Yeah, or they differ by 1, or they differ by 1. Yeah, we have to print yes if such a perfect pairing exists. Otherwise, we have to print no. Yep. So let me delete this one, man. Yeah. So now this is the question actually. Let's come to the input output part. See here. They have given actually here. This is nothing but the array. This is nothing but the array I was picking up of actually. 11, 14, 16, 12 actually. This is the number of inputs they have given actually. 1, 2, 3, 4, 5, 6, 7. You can count, right? So this 4 indicates this one number of elements in the array. Yeah. So you can clearly see here 11, 14, this one. So this is nothing but the number of inputs actually. You can just count 7. So this one you can just consider n actually. Just give me a second here. 1 second. Yeah, this is nothing but n actually. 7 whatever they have given. One input. 2, 3, 4. This one 5, 6, and the final one 7. Yeah. So we have 7 inputs and 4 indicates that number of elements in the array 11, 14, 16, 12. So we have 4 elements, right? 2. We have only 2 elements in the array 1, 8. 4 again 4 indicates the number of elements in the array, nothing but see 1 1 1 1 4 elements, 4 again indicates 4 elements, and so on, right? So I hope the input output part is completely clear along with the question, man. Yeah. So now let's do one thing. As we are familiar with the question as well as the input output part, let's discuss the approach followed by the complexities and then let's write the code. As usual, let's discuss the approach first. So just remember one thing before hopping into the approach part. So let me tell you one thing. So we will be solving this problem using the parity graph method. Yeah, this is based on the graph matchings actually. Yeah, the question. We'll be solving this problem using the parity graph method. Yeah, so let's hop into the approach part. Let's go step by step, man. We have the array. Let me consider the same input, the first input for the example. Yeah, for the approach. Sorry. So this one 4, 11, this one 14, 16 and 12. So let's consider this one array A. Array A equals, so within the array, let me write it like this. Let me give it like this. just ignore this 4 for now. We have 11, 14, 16, and 12 within the array. Array A equals 11, 14, 16, 12 for this particular this one. For the approach, we are considering the input 1, right? So first what we have to do, we have to count how many numbers are odd. How many numbers are odd? If the count of odd numbers is even, we can pair odds among themselves and evens among themselves, right? So then we have to output the answer S in that case, accordingly with the criteria that they have given in the question, right? If the odd count is odd, if the odd count is not even, if the odd count is odd, then we need at least one adjacent pair with the difference 1, right? So that's the criteria in the question, if you remember, right? You can just rewind the question and you can just check that part. Actually, I have said the same thing. If the odd count is odd, we need at least one adjacent pair with a difference 1. Yep. So just to allow the swapping pairings and make the parity counts pairable Yeah. For the array A here, we have 11, 14, 16, and 12, right? For the array A, we have 11, this one 14, 16, and 12. First, what we will do, we will sort. First step is we will sort actually. Yeah. After sorting, it will be 11. So let me make this one instead of 1. Let me go with this one. I have already explained this one. This one will be 11, 12, 14 as well as the 16. We have sorted this one in the ascending order. Yeah. So first step is sort actually. Then we will go with the this one, even count or odd count basically. Yeah. So first what we will do, we will be going with the odd count actually. Odd count is only one here within the array. You can just count here. 11 is the only odd element we have, right? So odd count is one here. Yeah. So I'll just go with the odd count here, one. Only 11 is odd here basically. We will check the what do we call, we'll check the adjacent differences accordingly with what we discussed earlier, right? So we will check the adjacent differences. So this one will be first, when we check the difference, it will be 12 minus 1. What's the difference? It's only 1. Yeah, it's 1. So we found such adjacent pair whose difference is actually equal to 1, right? So accordingly with the question, it's the adjacent difference is actually equivalent to the 1. We have found that pair, right? So after pairing, so we can just pair 11 and 12 now. After pairing 11 and 12, we can pair 14 and 16 by parity. So if the difference is 1, we can pair this one 11 and 12, and after pairing 11 and 12, as we have got the difference 1, we can just pair this one 11 and 16 directly. Yeah. So now in this case, when the difference is 1, if this one, when the difference is 1, we have got such pair, then we can this one return S, right? Accordingly with the criteria of the question, then we can return S, right? So in this case, the output that we got here is S, which is equivalent to the output that they have mentioned for the example 1 within the question, input 1 actually within the examples actually. Yeah, input 1 within the question. Yeah, so our approach works absolutely correct here. So what I insist you to do here, I insist you to try out for the other 6 actually. Just take any 2 inputs and just try to implement the same thing whatever we discussed now, so that you understand the question better. Yeah. So your way of implementation may be different. You might solve this one in a different way. Might be at that point of time, you might think of something better solution. The solution, yeah, the better approach actually. Yep. Your intuition may be better than mine. Yep. So that's what I wanted to say. I insist you to try out for the by considering different inputs actually. Yep. Now, yeah, the output that we got matches the this one. What do we call output they have given for the example 1 within the question. So our approach works absolutely correct here in this case. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, man. So what would be the time complexity here? The time complexity would lead to big O of n log n. The time complexity would lead to big O of n log n. Yeah, the time complexity would lead to big of n log n, because here sorting dominates. We are making use of the sorting. The first step itself, I said we will be sorting, right? So we sorted here this one array 11, 12, 14, 16 in the ascending order. So sorting dominates here. So overall time complexity becomes big of n log n, right? So it is sorting takes big of n scan. Yep. So overall it will be big of n log n. Yep. So the time complexity would lead to big of n log n. So what will be the space complexity here? The space complexity would lead to big of n, because we will be going with the array of size and we will split the tokens temporarily. So overall space complexity, we can just consider big of n in this case. Yeah. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n and big of n respectively. Yeah. Now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Let's start writing the code. I'll just come to the compiler part here. Yeah. So first, we'll be making use of the fast input and the output. Let's import the input output package. Just give me a second here. 1 second. Yeah, this is fine. The next part is we'll be making use of the different this one utilities. So I'll just go with the let's import the utility package as well. Next, let me go with here class main. So you can just give any class name that's relevant to the question. Yep. Next part is let me go with the main method here. Also, let me go with the throws input output exception, or else we'll be getting the error. Yep, it might throw the error. So now let me paste here this one. This is completely related to the input output part. So buffered reader for the fast input, print writer for the fast output, and NT. This is for the test cases actually. Yeah, by making use of the buffered reader variable, buffered reader dot readline. This is fine. Now let's move on with the logical part one. Yep. So we have to loop over all the test cases, right? So I'll just go with a while here. This is fine. Greater than 0 actually. Yep. So within the while loop, the first step here would be we have to read the n, nothing but E1, right? So I'll just copy the same thing here, this one. Instead of the T, I'll just make this one n actually, this one. The first line, we have to read this one, right? Number of inputs. So here, this is fine. This is fine. We are just reading n here. This is fine. The next part is we have to create the array to hold n integers, right? So I'll just go with int variable name array ARR here. So this one new int of size n. Yeah, size n. We know this. Next part is we need odd and adjacency this one variables, right? Accordingly with the approach that we discussed. Not add actually odd. Let me initialize this one to 0 as well as adjacency variable. Let me initialize this one to 0 as well. So after this, we have to read the array line and we have to split by the spaces. See here, we have to read this one array line, right? So we have to read the array line and we have to split this one by the spaces. We have space after 11, space after 14, space after 16, right? So we have to split them with the spaces. So I'll just go with here string. This is fine. S equals br dot read line. So this is fine. Let me make use of the word split here and leave the space, yeah, between the integers. Yeah, now the main part. So we have to parse each number. We have to parse each number. Let's move on with the for loop here. So this one will be for int I equals 0, I less than n. So let me increment the I. So within the for loop, first thing is we have to convert the token to the integer. And also we have to store that one in the array. We know this one, right? So let me consider this one iterated value of the array. So this one will be integer dot parse int here. So this is fine. So this one will be s of I. Yep. So if array of I is odd, nothing but the least significant bit is 1, then so we'll be making use of the this one bit manipulation here just for this particular this one line. So if the array of I is odd or if the least significant bit is 1, then we have to increment the odd count. Yep, then we have to increment the odd count. So let me write the if condition here. If let me go with array of I here bitwise and 1, if it is equivalent to the 1, then let me increment the odd here. Simple. Now let me come out of this one entirely. Now what we will be doing, let's sort the array to quickly find any pair, right? Any pair. Any pair, this one we have actually a condition. Just give me a second here. We have to sort the array to quickly find any pair that differs by 1, right? So that differs by 1. If it differs by 1, then we can um, create another pair next to it and then we can just print s directly, right? So that's what the criteria actually, uh, that's what the approach that we went with within the actually within the approach. Yeah, that's what the approach that we went with, sorry. Yep. So I'll just go with here. we have to sort, right? First step. So I'll just go with here arrays dot sort. This is fine. So let me pass the array here. Yep. Now let's do one thing. Let me go with a for loop here. So this one will be for int I equals 0, I less than n. Let me increment the I. So this is fine. So within the for loop, if any adjacent different equals 1, then we have to set the adjacency flag, right? Then we have to set the adjacency flag. So I can just write in this way: if particular current element array of I, so minus the previous element array of I minus 1, if it is equivalent to the value 1, then let's set the adjacency variable to 1. Yeah, let's assign the adjacency variable to 1, and then we have to break early, right? If this one found is enough, right, for us. So let's break out actually. Yep. So let me come out of this one entirely. Now, if the number of odd elements is even, we have to pair by the parity possible. We have to pair the parity possible. Yeah. Or if there exists and this one, what do we call adjacency pair with the difference one, then also this one we have to go with a we have to pair and we have to print s in that case. Yep. So that's what we need to do. So how can I write this one? I have considered the variable pw for the print writer actually. I'll just go with the print writer pw dot println here. So this is fine. Odd modulo 2. So if it is equal to 0 or adjacency, if it is equal to 1, then let me go with the s actually. Else, let me go with this is fine. Yeah. Finally, what we'll do, we'll flush the output buffer to ensure all the answers are printed. So you can just flush or you can just close the output by making use of pw.flush or pw.close here. So I'll just go with a flush here. This is fine. Yep. Now we are done with the coding part, man. We are done with the coding part. So before checking the code with the different inputs, so let me paste the signature starter template. So I'll just come here. Yeah. Now let's do one thing. Hmm. Let me copy this one. The output that we need to get here is S no followed by 4S and no. Yep. So let's check the same. Have the what's wrong here? This is fine itself, right? What is wrong here? Let's do one thing. Let me add one more this thing just for the safety here. I hope this has to work now. Sometimes because of the parenthesis itself, it was not working, I believe. Exception in the thread main array out of bounds and for 1 second for loop whatever I have written. So this is fine, man. Just give me a second here. See here, what mistake I have done here is in the line number 40, I have given int I equals 0. And we are and I have given in the if condition if array of I minus array of I minus 1 equals 1, right? So we are trying to access array of minus 1 when I equals 0, which doesn't exist at all, right? So in this case, we have to get the runtime error itself. Yep. So here we have to start from the 1, not 0 actually. Yeah. Accordingly with what condition I have written, we have to start from 1 itself. Yeah. So now if I run this one, I have to get the correct output. Yeah. So yes, no followed by 4 times S and no, which is absolutely correct. So the code is small and it's easier one actually, easy one actually. Yeah. So let me copy this one entirely. Now let me come here, hit the submit code. In the submission part, let me paste the code, select the C, similar pairs and submit. So yeah, this is going to be the last problem on the graph matchings actually. Next, let's move on with the graph and trees, right? Graph with the trees actually. Yep. So we are left with very few problems, man. I'm not gonna lie. So we will be finishing this one almost. We are left with some 5 or 6 problems. That's it. Yeah, after this particular problem. Yeah, 6 problems, I believe. Yeah, so we'll finish it off within 3 to 4 days. This one. Yeah. After that, I don't think I'll be doing the videos on this one. This much I can make the video in the future, no doubt. But uh, with this much detail, I'll not be making the videos on the this one Codeforces, I believe. Yeah. So I'll be moving on with other things. So I have to move on with other things, right? So we will be solving the problems. I'll be giving the content contest. I'll be giving the contest this one. I'll be practicing if I want to. So I'll do everything, but I don't think I'll do this thing for the YouTube further, right? So we have solved around. Well, I have solved many problems, man, including this one in the Java. I have solved almost 170 problems for the YouTube, and in the Node.js, I have solved around 50 problems. Yeah, segment tree as well as the graph and this one dynamic programming. In the Node.js also we have solved. If you want to check, if someone is giving CP in the Node.js, please do check it. If you you will get some idea if someone is starting actually, or if you are giving, if you want to learn something mainly based on the segment tree, this one dynamic programming as well as the this one graph, you can just check that one. I have solved around 15, 15, 15, I believe. I don't exactly remember. So it's actually 15, this one 15, 25 and 10, I believe. I think so. 25 DP problems, 15, or one thing, 30 DP problems, 10 and 10 segment tree of NVIC tree as well as the sparse table 10 problems and 10 problems on this thing, I believe, in the Node.js, maybe. So you can just check the playlist. So we have solved a number of problems already, all right? Before the programming language is different. So here we have solved 170 problems clearly in a structured way, man. There also it was structured itself, but we have solved only problems on this one using the Node.js. We solved only the problems on segment tree, Fenwick tree, sparse table. So this one, what do we call the other two? Dynamic programming, as well as the last one was on the this thing graph actually, graphs. Yeah. So now this one we have completely solved with detail 170 problems, meaning covering almost all the important topics. But yeah, started with the arrays and strings actually, arrays, strings, linked list, sliding window. Yeah. So this one backtracking, this one hash map and hash set, mainly hashing actually. Yeah. Every this one, most of the important things are covered for the CP actually. Yep. So we will be solving this one. There are many things we have solved within. So whether the topics may be this one, number theory, we have used most of the algorithms, number theory algorithms, we have used graph algorithms, we have used DP algorithms. Yeah, we have used linked list algorithms. We have made use of this one. What do we call? Uh, Arrays and strings algorithms. Yeah, we have made use of the this one greedy algorithms. Yeah, most of the topics we have covered almost. We are left with the last six problems actually. We have come to the end actually. Last 3 or 4 days we'll be finishing with this one. We'll be finishing this one. Yep. So total, I said that we'll be solving around like 50 problems in the graph, right? So almost this is the 44th problem that we have solved. Yeah, we are left with the six problems. We'll be finishing this one very soon. Yeah, all I wanted to say is we have completed, or we have solved, we have completed all kinds of this one important stuff. That's what I wanted to mention. Yeah, we have done this one structurally, right? Starting from arrays and strings, right? So we are ending this one with a this one. What do we call the topic graphs? Actually, we have made use of several graphs algorithm, whether it may be flow algorithms, whether it may be shortest path, starting from the DFS and BFS, whether it may be Bellman Ford, this one, Dijkstra, Johnson, Dinnick, yeah, Floyd Warshall, push relabel, it may be. So this one, recently we have made use of the conics theorem as well in one of the problems. Yeah, some important theorems as well. And we have seen different kinds of graph actually. This one directed acyclic graph, this one cyclic graph, directed acyclic graph. So we know the topics, right? Cyclic graph, acyclic graph, bipartite graph, right? So adjacency list, adjacency matrix. Then we have covered most of the things, most of the topics. Yeah, if you would have solved with me, or at least if you would have seen the video, you will be knowing certain topics for sure. Yeah, we have solved mostly the difficult ones. So not to show off actually that I'm solving the difficult one, because when you solve the difficult one in detail, you'll understand, or you'll try to this one explore certain things which you don't know. And uh, when you are doing the CP actually, you will be having this one good grip on the data structures. Uh, I wouldn't this one disagree this one. So I agree that you will be having good grip on the data structures as well as the algorithms, man. Yeah. if you do the CP. Yep. So if you solve in detail, if you practice, if you have enough time, if you are practicing, then you will have the good grip on the certain algorithms, not certain algorithms, most of the algorithms, I would say. Yeah, most of the algorithms, and as well as the data structures as well. Yep. So that's what I wanted to say. So here, the verdict that we got here is accepted. Let's move on with the problem thing. Here, the verdict that we got here is accepted, right? So, yep. Um, I hope the solution part is completely clear, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.